Hello everyone, welcome to this challenge yourself problem where we have all members of a family of alkane compounds that contain carbon, which is the C atoms, and hydrogen, which is the H atoms. And this table is to help us to look at some of the compounds. Alright? And there is actually some form of number patterns in terms of the number of atoms for carbon as well as hydrogen that we are going to investigate soon. So let's take a look, and I'm going to, at this point, zoom in on the butane and pentane, because part A requires us to find the values of W, X, Y, and Z, okay? And at this time, right, if I look at the pattern for the carbon atoms, if n equals to 1, it will be 1. If n equals to 2, 2, 3, 3, 4, W will be 4, 5, Y will be 5, right? So this is pretty straightforward. I'm going to just take a note down here that this one I could just rewrite it as C. 4. This one will be C. 5. As for the H, let's take a look at the blue color. 4, followed by 6, followed by 8. 4, 6, 8. What do you think is the next number? Yes, we always add 2 to it, yeah? So this one will be 8, 10, 12. Alright? And with that in mind, we could just go back. Let me zoom out again. And we could then write the answer for part A at the side, where we have our W equals to 4, Y is also equals to 5, and our X equals to 10, and our Z is equals to 12. Now, for part B though, write down the molecular formula of an alkane compound which has n number of, very important, carbon atoms, meaning that they would want us to write down the C in terms of n for the number of carbon atoms as well as the hydrogen, okay? And so I'm going to do this separately. I'm going to look at the C, and I saw that when the number of carbon atoms is 1, C is equals to 1. When it is 2, C is 2, so therefore, very straightforward, I will be able to get C n, number of n items. But for H, I do want to write out all the blue numbers out so that we can try and devise a pattern for this. What do you notice? That we always plus 2, plus 2. Do you saw that? Can you see that? That means we always plus 2, and this becomes a number pattern that has a common difference. Okay, so this is important. This means that this is a common difference pattern. And once we have ascertained that this is a common difference pattern, we could tap on this formula to help us get the n term for hydrogen atoms here. Where now we have our term 1. The first term is number 4. And we are going to add, we always add 2, yeah? So 2 is actually the common difference. So D will be 2. And I have 2 times n minus 1. And we just need to continue to expand and simplify. So I will have 4 plus 2n minus 2, 2n, 4 minus 2, 4 minus 2 will be equals to positive 2. And therefore, for part B, I will be able to get this answer. So come, let me just shift to keep. So the answer will be C and H. 2n plus 2. Alright? Comes from here. Done. Hence, or otherwise, find the formula when we are given that the carbon atoms is 16. So I'm going to write it here. Now that we know this, it is quite straightforward now. N is equals to 16, meaning the answer will be C16. H, 2 times 16 plus 2. This will be the final answer. With that, we have come to the end of this particular example. So if any point in time in this video, you like this video, do give it a thumbs up. And thank you for watching. Have a nice day.